Okay, pre-calculus fans, we're looking at what are called polynomial inequalities. Earlier in the year, we looked at what's called a quadratic inequality. Now we're going to look at polynomial inequalities, and our polynomials are all going to be in factored form, so you don't have to worry about coming up with the factors or doing the synthetic division. Okay, I'm teaching you techniques here. All right, so first of all, let's talk about this quadratic. Okay. But in order for us to solve this, we have to make sure it's equal to 0 first. Okay? So all I'm going to do first is I'll subtract 5. So I'll have x squared plus 3x minus 10. I'm going to make it equal to 0. The only reason why I'm making it equal to 0 is so I can come up with my critical points, the points on the number line, just to refresh your memory. So I'm going to factor that. Nice and easy. Plus 5 minus 2. So we have negative 5 and a 2. These are your critical points that we put on the number line. These are the roots. So here's my number line. So negative 5 and 2 greater than or equal, so it's closed. And now, when we did the quadratic inequalities, well, all we had to do was just worrying about one region. We always worried about the middle. If it was true in the middle, we shaded in the middle. If it was false in the middle, we shade on the tails. Because we only have 3 regions, okay? That's it. There's only 3 regions in a quadratic inequality. And I always just said, okay, we'll pick 0. If I plug in 0 up here, do I get true in the middle or false? What's this? 0 plus 0, negative 5 is bigger than 5. And that's not possible. So it's false in the middle, so we had a shade on the tails. Okay? And then we wrote out our solution. Negative infinity to negative 5, bracket, parentheses. That's a negative infinity. Union, or, bracket on the 2 to positive infinity. All right. So pretty straightforward. Well, I'm going to show you a different technique for solving this. It's not doing a test point. Okay? We're going to look at the factors. So I'm going to draw my number. I'm going to do my number line again. Put my critical points down. And I'm still going to shade. Okay? I shade for a reason. You'll see why when we do our other problems. So I want to know if I'm going to be using brackets or parentheses. That's why I do my closed circles or open circles based on the inequality. Now, the technique I want to show you is doing pluses and minus signs. So I'm going to start with the x plus 5 factor, and I'm going to look at the x minus 2 factor. And what I want you to realize here is the following. Okay? Remember, at x plus 5, it's equal to 0. It's called a root. So my question to you is, what happens when we're looking at numbers that are less than negative 5? What kind of values are coming out of here? So think about a number that's less than negative 5. Hopefully you'll say negative 6 or negative 7 or negative 8. What if I said negative 50? Oh, negative 50 plus 5 is a negative number. So think about this now. At negative 5, it's equal to 0. That's your dividing line. Left of negative 5, because it says x plus 5, it's a negative sign. And then anything to the right, the numbers coming out of here would be positive. Okay? Remember, you just plugged in negative 50. That's certainly less than negative 5, and negative 50 plus 5 is a negative number. I don't care what the number is, I just want to know if it's positive or negative. And then anything to the right of negative 5 will make a positive result. If you're not sure, pick a number that's to the right of negative 5. Well, to the right of negative 5 could be a negative 3. Well, negative 3 plus 5 is positive. Okay, no matter where we are on the right of negative 5, we will have a positive result, according to this factor x plus 5. Okay. Now, I'm going to do the exact same thing for x minus 2. Well, x minus 2, the root is 2. That's when it's equal to 0. So we got stuff going on to the left of 0 and to the right of 0. To the left of 0, we're going to think of a number that's less than 2. Okay, I'll think of 1. What happens when you plug in 1 there? It's a negative result. So no matter how many numbers that we plug in that are to the left of 2, the result coming out of this factor will be negative. And then anything to the right will be positive. I want you to think about that for a second, what I just did. I got these pluses and minus signs on here on my little grid. Okay? Now, what's the operation between the x minus 2 and the x plus 5? That's right, it's multiplication. Well, what happens when I multiply these two negatives together? It's positive. Perfect. What about here? That's a negative result, and that's a positive result. So, look at this. So when this quadratic, well, I don't want to say equal to 0, was greater than or equal to 0, I'm going to put my greater than or equal to sign back now, was greater than or equal to 0. Greater than or equal to 0 means what? That's right, positive. So in what regions is our product positive? That's right, negative times a negative and a positive times a positive. Isn't that exactly what we talked about right here? That's right, positive here and positive there. And also, by the way, if you think about this as an axis, isn't this a parabola that we graph? So if I were to sketch my little parabola here, if I was to sketch the parabola, I'm not saying you have to do this. If this is the x, think of this as the x-axis. Anything above the x-axis is positive. Anything below is negative. Isn't this a negative result? Isn't that where the curve is under the x-axis? And then everything here is above the x-axis, so they're positive. There you go. I just gave you the solutions. We have the solutions for when this is greater than or equal to 0. Okay? All right, let's look at this one. So I'm going to start by doing my number line. Okay, and on the number line, I have to put in my roots, my critical points. They're my roots. Now, my suggestion to you is write down these numbers somewhere. The root here is -1, -2, and a +5. You make sure you put them in proper order. If you can't put your numbers in proper orders, you better ask somebody what comes first, -2 or -1. Okay, here we go. -2, -1, and 5. I don't care how far apart you spread them out. All right, what kind of circles are we using here on these roots? That's right, they're closed circles. All right, now notice here how many regions we have. We have 1, 2, 3, 4. I'm not going to pick a test point. If I pick a test point, I have to pick a test point each one of these regions to see where it's true or false. That is way too much work. I'm just going to do my plus-minus scheme. I'm going to start with x plus 1. Okay, then I'll do x plus 2. Then I'll do an x minus 5. So I'm going to start with x plus 1. Well, here it is right here. At -1, I'll put a little dotted line here to identify my regions. At -1, that factor is equal to 0. Anything to the left of -1, what kind of numbers are coming out? Are they positive or negative? If you're not sure, plug in a number that's less than -1. I don't care how less than -1, just make sure it's less than -1. Okay, fine, you want to use -50. -50 plus 1 is a negative result. So anything to the left of -1 for x plus 1, the factor, will be a negative result. And then anything to the right will be a positive result. I don't care how many spots you have to put plus signs in. It does not matter. All you care about is -1, your critical point. All right, now we're on the next factor, x plus 2, which is negative 2. Anything to the left of negative 2 for this factor would be, that's right, negative. The rules don't change just because we change our numbers. We're just looking at a different region. And now anything to the right, I don't care how many regions there are, it's to the right of 2, negative 2. That's right, it's going to be positive. And the last but not least, our factor of x minus 5. Here it is right here, 5. Anything to the left is, that's right, negative, and then anything to the right is positive. Notice I did this without doing any test points. I didn't think of numbers to plug in. That's too much work. All we got to do is worry about the individual pieces and then think about it. What are they doing with each other? That's right, it's one big giant product. So what am I going to do with these? Negative times a negative times a negative. Negative times a positive times a negative. All right, what region are we looking for? Well, then we're going to go back to our inequality now. What does the inequality say? Less than 0, less than or equal. What numbers are less than or equal to 0? That's right, negative. So I'm going to circle the regions that when I multiply the signs together, I get a negative result. Well, there you go. There's a negative result. That's positive. Negative times a positive times a negative is a positive. Here's a negative result. This is positive. Okay, we did all the hard stuff. Now the easy stuff is just identifying the solution set. Got to state the solution. That's right. Less than negative 2. So negative infinity to negative 2, right? Bracket, parentheses, or union. You can use the union symbol in between negative 1 and 5. We just answered the question. I didn't do any plugging in numbers. Oh my God, I got to plug in numbers. No, you don't. You plug in numbers, you only make the work harder for yourself. All right. Now we're going to look at some factors that have exponents on it. Notice, by the way, I don't care what degrees these are. Yes, this is a third degree equation. You know what? You also know what this graph looks like. If I were to sketch this thing, that's right, this is negative, so the graph's down below. This is positive. That's right. Here's your positive. There's your 0 again. This is negative. The curve is under the x-axis, and then we finish high. Okay, there you go. The function is negative. The function's positive. The function's negative. The function's positive. That's it. That's what the inequalities mean. All right, let's look at this one. Yeah, by the way, this is a 6th degree. Right, 2 and 3 is 5 and 1 is 6. But you know what? Who cares? We got to do the rules the same way no matter what. Oh, there's my number line. Well, you got to be smarter than the average bear here. So this is a positive 3, negative 4, and a negative 6. Put them in the proper order. If you put these in the wrong order, you're going to get the problem wrong because you're not going to know what the heck you're looking at. Okay, so you got to make sure you put the numbers in the proper order on the number line. Negative 6, negative 4, and 3. And notice, strictly greater than. There's no equal sign, so make sure you use your open circles for that. Okay? You got to remember, we cannot include these numbers. All right. Oh, look at this. I'm going to focus. Let's look at this one right here. It says x minus 3 quantity squared. All right, x minus 3, and I'm going to put squared. I'm not going to write it twice. It says squared. What does square mean? Right. Any result that you get is always going to be positive. So here's 3 right here. No matter left or right, it does not matter. That thing says squared. Okay? You're always going to end up with a positive result. So pluses all the way around. You square a number, it's positive. All right, now I'm going to go to my x plus 4 cubed. All right. All right, what happens when you raise a negative number to an odd exponent? That's right, it stays negative. Okay? So the exponent here doesn't do anything for us in terms of signs. If we raise a negative number to if we raise a negative number to an odd exponent, it's still negative. All right, so There's the negative 4 right there, right? To the left, we are what? Negative. And then to the right, we are positive. It's cubed. Nothing happens with the signs. And then here I just have x plus 6. Okay, to the left of negative 6, it's negative, and then everything to the right is positive. And if you guys have to, put your little dotted lines in there just to identify your regions to make it neater for yourself. The neater you are here, the easier your work is. All right. That's right. Bigger than 0, greater than 0. So when we multiply these together, we need positive results. So where are we positive? All right, we're here positive here, and positive there. That's right. We got 3 regions where this thing is positive. So, all right, so negative infinity to negative 6, parentheses and a parentheses. That's right, we don't include negative 6. Okay, union or the word or, they're the same thing. Now I can do one of two things. I can say negative 4 to infinity and then exclude 3, or we can say negative 4 to 3 or 3 to infinity. Your call, what you want to do. Okay? So we can do negative 4 to infinity, and then we just have to say x does not equal 3 because we cannot include 3 because that's an open circle. Okay? Or union negative 4 to 3, and then or 3 to infinity. As long as you have the parentheses on them, you're not including them. So either this or this, it does not matter. Pick your favorite. They're the same results. Okay? They're the same. And again, if you wanted to look at this as a graph, positive, all right? So positive here, go through the axes, turn, actually this is the negative 4 is cubed, so you turn and you do a little drag through and then come up, bounce, and then come up again. Okay. All right. I don't know if I want to do the last one or not. Oh, look at this. Oh, look at that. There's a negative in front of that x. How does that affect our work? Well, we could just divide everything by negative 1. So this would come with plus. What happens when you divide a negative? What happens to the inequality when you divide by a negative? That's right, it flips over. So we could do that if we wanted to. But I'm going to keep the negative x there. I'm going to show you what happens with it. So, by the way, what are the zeros? 0, negative 3, and a positive 4. Let's start with the negative x. Oh, that's good. I got to put this stuff in first. Negative 3, 0, 4, and greater than or equal to, so we got closed circles. All right. I'm going to start with the negative x. What happens when we do negative x? Well, think about this now. When we're in a normal, if it was normal x, if it was a positive x, to the left of 0 it's negative, and to the right it's positive. But there's a negative in front of it, so what happens when I'm to the left? That's right, you get a double negative. And then what happens to the right? That's right, it's negative. That's all. That's just backwards. No big deal. All right, now we're at x plus 3 quantity squared. All right, it's squared. Nothing changes. Everything's positive. All right, this one's even x minus 4 is quantity squared. Look at that. It's all pluses all the way across the board. So what are we looking for? Bigger than 0, right? Ah, greater than 0, negative and a negative. So what's our solution? Well, we could say negative infinity to 0. That would include the negative 3. Okay, we could do that. We could go negative infinity to 0, bracket, parentheses, okay? But I left out something. What did I leave out? No, negative 3 we've included here because of it's included in there. That's right, we left out 4. 4's tagging along way over here. So then you would have to include x has to equal 4. That would be your solution set. Okay? There you go. There's your solution. And if you wanted to separate this and say, negative infinity, bracket 3, bracket negative 3, bracket 0, great. But then you still have to remember to include 4. All right. Oh, let's just do one more. They're easy. They go fast. Last one. All right, yes, negative 5, negative 3, and a positive 4. Which one goes first? That's right, negative 5, then the negative 3, then the 4. What kind of circles? That's right, they're all open. All right, I'm going to do my... Now, I want you to notice something here. If I actually put my factors down in the order in which they appear on the number line, there's a specific pattern that you will see. Watch the pattern. Then I got my... Well, actually, it's not going to happen with this one, but all right, no, it doesn't matter. So x plus 3 squared, and then x minus 4 cubed. All right, yeah, there we go, negative 5. To the left, it's what? That's right, left it's negative, right positive. Unfortunately, this is squared. So when we do this one, this line right here, okay, here's your little dotted lines just to separate the regions. The neater the better. Right, everything's positive. It's being squared. Nothing changes. There we go. 4 is the last one. It's cubed. That's right, nothing happens to your signs. If you're cubing a negative, it stays negative. If you cube a negative, it stays negative. All right, so left we're negative. All right, there's the 4, negative, negative, and then positive. Okay, you can almost see like a stepping motion if this was, if we put these in order. So, if this wasn't squared here, it would have been negative, negative. So it's almost like a stepping motion in terms of the signs. Okay, all right, that's the pattern you would have seen if these were just regular no exponents. Okay, if you put them in order in which you see. Okay, all right, so what's our solution then? We're looking for less than 0. We're looking for negative results. Now, there they are, here and here. Yeah, so there's 2 ways of writing this out. We can go negative 5 to negative 3, union, or the word or, negative 3 to positive 4. Notice I'm using parentheses because they're open circles. Or we can say negative 5 to 4, and then just remember to say x cannot be negative 3. Either way, they're both correct. Correct, correct, doesn't matter. Close your eyes, pick your favorite one. All right, we just did a whole bunch of polynomial inequalities.